Alright, we're gonna start the experiment for RCD for the today's lab. So we have set the whole circuit right here, but before we proceed, we need to make sure that everything is off at the beginning. So the power supply is off, as you can see, and switch box is off, and the MV1300 power supply 3-phase supply is off. And now we can move on to the step A on your page 8 of the lab manual. So the step A, what we're going to do, we're going to set the input voltage to 22 volt AC. So first what we're going to do, turn the power supply on. So you can hear that noise at the background which says the power supply is on. So from the lab bench to the MV1300 power supply. So now we need to set the voltmeter to AC. So as you may see, now it's on AC, it's measuring the AC voltage. And now we need to turn the MV1300 on and set the voltage to 22 volts AC. We shouldn't go beyond the 22. So let's try to make this one close as possible to 22 volts AC. Okay, it's pretty much close enough. Now we can leave this setup and we need to proceed into the next steps. At the part B, we are asked to, the step B, we are asked to set up the circuit which can be appeared on the step G, E and F. So the first, I'm going to explain how to set the first circuit on the step G. So what we have to do, as you may see on the image on your left hand side, so we need to take a connection out of the line C of the RCD, as you may see. So now you can see we have input side, neutral, the line A, B and C, that's our input side, and this is the output of the RCD. So likewise we have 3 connections, but on the image 1 what we need is only one connection which is coming from the line C and go through one resistor and connect it back to the neutral. But we have two places to connect. If we connect this one from here to here, we're going to have 2 resistors, but we only need one. Since that is the case, I'm going to connect this one right here and connect it back to the neutral. So you may see now we only have one resistor in the line, and now we have completed the circuit. So now what's going to happen with the RCD, if the algebraic sum of the current flowing into the RCD, if it's not 0, there will be residual current. So that will cause the trip of the RCD. So now you need to guess what's going to happen with this circuit setup. So I'll give you the time and then we can see actually will that going to happen or not. So I have guessed what's going to happen, so I can see. So let's proceed and turn on the switch box. So it didn't trip. So that is what should happen. You can see here, so the current flowing in is going back through the RCD, so there is no any residual current, so that means it won't trip. Now let's turn this one back off and move on to the second circuit, which is on the second image of the step D. So here now what's going to happen is the current path which is coming out from the line C should not go back to the neutral of the output side. Instead, it is going back straight back to the neutral of the input side. What means it bypasses the RCD. Now in this case, you can clearly see, so the current coming in to the circuit breaker and is going back and bypassing the circuit breaker RCD. So what that means, there's a residual current flowing. So you need to guess what's going to happen if you turn off the input side of this RCD. So I'm going to turn this on. You need to guess what's going to happen. So as you may have guessed, since we have a residual current, it has already tripped. So that's how this RCD works. So let me turn this back off, and now we can proceed the same steps with the following images or the circuit diagrams that you may find in step E to F. So I'm not going to show each one of them here, but I'll explain the circuits for each one of them in the following slides, and let's have a discussion on that.